All right. Thanks, everyone that's with us today. We have a nice audience. I'm Gil Friedrich. I'm Avanan CEO. And the topic we're going to cover today is really a deep dive into Avanan's anti-phishing algorithm. And basically, why we're catching things that others miss with our algorithm. Now, if you've been with us in some of our previous webinars, you know that normally we focus on either attacks or new information, more educational, etc. Today is slightly different. We really focus on Avanan and on what we do. But it's not salesy in the sense that it's going to be pretty technical, and we'll dive into the technical details of under the hood, how things work for Avanan's anti-phishing. Last note before we start, I'm here with Michael from our team. So if you have any questions, please just write them into the little chat window, and we'll try to address those questions as we go. We also have a Q&A time at the end. And then last comment is, if you'd like, you can register on our website just for reports, updates, and attack briefs. So we won't send you any marketing information or anything like that. Just if you are interested in our new phishing attacks reports, we have a special mailing list for that. All right, let's start. So as we go into describing the problem we solve, real quick, just to describe the problem. So, we believe Microsoft is doing a pretty good job, the best they can for sure, and they're not bad at it. Nonetheless, if you look at pretty much any recent security report, phishing seems to be a huge problem. In the Verizon breach report from February this year, they said 90% of breaches start from email. And they said user credentials in Office 365 specifically is the #1 target. So that's obviously a problem for many of us. What we're also hearing a lot from customers is, forget about the security, the risk for data, and the organization in general, when they get compromised, they just spend a lot of time on this issue. So end user report phishing, it goes to somewhere, they need to figure out what to do with it, especially as you go into the larger organizations. They just spend a lot of time trying to clean up after phishing emails that went through. And this is a quote from Gartner from the end of last year, basically, quoting, I guess, the customers they've been speaking to their clients, saying that although Microsoft invests a lot in it, many clients report that it's not good enough. Dissatisfaction with EOP and ATP, and looking for third-party solutions. So this is the scope in general. From our perspective, we try to ask ourselves, why is it that Microsoft misses a lot? And by the way, here you can see these numbers are taken from our global phish report. That's also downloadable from our website. But we went through the same exercise where we analyzed, thousands of emails, tried to understand thousands of phishing emails, tried to understand how many Microsoft caught, how many they missed, etc. What we found is that in general, they marked as phishing or spam and put in a junk folder about 70%. They missed, meaning they scanned and marked as clean, about 25%. And maybe as interesting, about 5% came as whitelisted. So not even scanned for different reasons. So in total, what we found is that about 30% of phishing attacks just bypass the default security. Not to over speculate, but when we ask ourselves, why is it that Microsoft misses so much? And again, it's not, they have very talented engineers and they put a lot of money and effort in it. We're trying to still understand what's inherently different when Microsoft tries to solve this problem versus, some of the third-party vendors. And we identify at least two things that are, long-term limitations when you are the default security. The first is that they're very, very sensitive to false positives. So their ability to do something per customer is limited. Their ability to, make a mistake and recover quickly at their scale is pretty limited. And if they are not sure, they'll normally choose the option of just let the email through. I even heard from, some of their engineers that work in spam that saying something like, one legitimate email that is blocked is worse than 10 phishing emails that go through. That's sort of the way they described it. It might be the case when you have 200 million mailboxes that you need to protect and you don't have any interaction with your end users. But for a lot of our customers, they would rather be safe than sorry. So they would rather take a different approach. But this is something that, as a default security, you have a problem, to block legitimate email, to take even the risk of blocking legitimate email. The other difference, or the other limitation they have, and this is maybe more fundamental, is that they're the default. So if you're a hacker and you're trying to bypass Office 365, you're not going to release an attack that Office 365 knows how to block. Not only that, as soon as the attack is getting blocked, you know this as well because you are also an owner of an Office 365 email. And this is a practice we see, with hackers a lot, where as soon as they get blocked, they know about it pretty quickly. As soon as the URL is identified, they know about it pretty quickly, and they just move to the next one. So that's how we can explain this huge miss, just in the sense that when the phishing attacks go out, as soon as they identify it, the campaign stops and they move to something else. But it also, maybe more fundamentally, has to do with the fact that if you use the default, you have thousands or hundreds of, maybe tens of thousands of hackers that are spending their day and night trying to figure out what would bypass Microsoft. So this is sort of the background of, the numbers are the numbers, but maybe why we think just the default is not enough. Let's start talking about us. And this is a little bit of a high level, but just to describe the flow of the presentation. So the way Avanan deploys its anti-phishing layers is fundamentally different. And we'll touch that. We use a combination of API that is also inline. But then what this gives us, it gives us visibility that other tools don't have. And with that visibility, we're able to develop, AI and basically a security layer with intelligence that other solutions just don't have because they don't see that type of information. So this is sort of the flow, and we'll dive right into it. First, how is it that we deploy? So you can see here this flow of an email where if you had your traditional email security gateway at the front, it would sit before Microsoft Security. Then you have Microsoft Default Security, EOP. Then you have Microsoft Advanced Security, ATP, sort of their acknowledgement of the fact that default security is not enough. And then you have the end users' inboxes. The way we install through API, once you approve our application and starts moving users to inline, is really between the Microsoft security layers, whether you have ATP or not, and the inbox itself. We're also connected to the inbox itself for post-delivery. This is normally a market recognized by Gartner CESS, Cloud Email Security Supplement, and we'll touch that as well. So these are the two connection points that we have into Office 365. Before the inbox, so we can scan and block attacks, and inside the inbox, so we can clean it if it was missed after the fact. Now, what does this location give us from a visibility perspective that is not available to, to your standard secure email gateway that sits in the front? The first thing is that we see what the what the default or what the Microsoft security in this case is missing. And we really focus on that. If you think about AI, normally AI is trained on a data set and is as good as what data set you feed it. We really feed it with, you know, what the holes in Microsoft Office 365 and the holes in Gmail, if you're using us for Gmail, for G Suite. By doing this, we don't train it on, you know, we call it the background noise of the planet, the easy spam attack that Microsoft blocks, the, you know, noisy mailers, marketing, etc. All that Microsoft takes care of. We really train it on what's being missed, and this is why the AI becomes, you know, very good at catching that. The other thing that we do differently, and you'll soon see some of the examples, as we're focused just on that, we see a lot of obfuscation methods and other tricks hackers are trying to do in order to bypass the default security. Now, in general, when you think about the security tool, the first question, you know, vendor asks themselves is, am I parsing this message correctly? Am I also vulnerable to this? And obviously, this is a question we ask. And in some cases, you know, in all honesty, we've seen attacks that the obfuscation, we were actually vulnerable to it as well. So besides fixing that and making sure we properly parse those messages, every time we see one of those, it becomes what we call indication of attack. You know, not our term, not taking credit for it, obviously an industry term. But once we have this as an indication of attack, now this becomes another indicator within our AI algorithm, and a pretty accurate one. It's a little bit, you know, if I'm trying to use this for the example, what an IPS would do for network traffic. We identify that when hackers are doing this trick, it's very, very likely, if not completely positive, that they're actually trying to bypass Office 365. And by having that as another component in our AI, we're really capable of finding the most sophisticated attacks. By the way, as a side note, fortunately for us, the more advanced hackers will not use just one method in their phishing emails they send. They'll use 5 or 3 to 5 different methods to obfuscate the attack. It's fortunate for us because we just need one in order to incriminate or have them self-incriminate themselves. But as our security analysts go into their email, they're saying, all right, so here's a new indicator I've never seen before. Let's add that as well. And this is how we got to hundreds of indicators that allow us to identify those attacks. The other sort of, same thing, but slightly different, going back to where your SEG would be deployed. When you install an SEG, you need to whitelist it within Office 365. Basically, you need to tell Office 365 to trust emails from, Proofpoint or Mimecast or someone else. What it means, and we wrote a blog about it with a very specific example, we called it 1 + 1 = 0. What it means is that attacks that Microsoft would have blocked, Proofpoint plus Microsoft would miss. And the things that become disabled once you whitelist, malware is still being scanned by Microsoft as well, but the links get obfuscated because Proofpoint and Mimecast, they add their own what they call safe links, and so now Microsoft cannot use their own intelligence to scan those links. And the other component just has to do with all the information, all the intel they have about senders, sender reputation, SPF, and so on and so forth. All of these indicators that eventually feed into their spam and anti-phishing algorithms basically are disabled with the standard MTA configuration. For us, we scan after. So, Microsoft, they do their best, and only then we scan. So when you look at the first bullet item here, what we say is that we add security, we don't replace it. Whatever you have from Microsoft, there's no question, are you better or not than Microsoft? Because you're not replacing Microsoft. Microsoft will do their best, and then we'll add another layer on top of that. And then finally, if you think about the methods of deployment, every hacker in the world knows if you choose Proofpoint or Mimecast because you just change your MX record to them. And so they can design their attacks to things that bypass Proofpoint or Mimecast. at the first point that if they bypass them, they're in your inbox, because Microsoft won't scan it again or will be limited in what they can do with the email. And you can see how basically you told everyone what security you're using and you disabled something else. You rely on them 100%. It's not the layered approach that security professionals are being educated to prefer. And as a side note, if we're still working on the blogs, but we have two very interesting attacks. One specifically against Mimecast, where hackers are sending release from quarantine messages as if they came from Mimecast. It bypasses Mimecast, and then when Office 365 gets it, they say, legitimate email, I just got it from my MTA, which is Mimecast, so all looks good. And we have a similar attack against Proofpoint, where it's an email service trusted by Proofpoint. Hackers are using it to send attacks, but they send it to specifically to Proofpoint customers because they know that's where the vulnerability is. So we're still collecting the data on these two blogs, but if you register to our mailing list, you'll get them as soon as they become available. So that's sort of the high level of, just the core better detection, being able to scan afterwards in a hidden mode that's very, very focused on the gaps within the default security. This is just a quote from a customer that ran us on their executive team for 15 users, 30 days. They're a little bigger, they're about 5,000 employees, this customer, but they ran a limited POC, literally us, Proofpoint, Mimecast side by side, and you can see the numbers they reported. It was, they reported that we identified 162 attacks within that time period, where Proofpoint reported 101 and Mimecast reported 69. So, this is sort of, we don't have a lot of data like this. Not every customer provides us with this level of detail, but this customer did, and it sort of gave us at least one example of the ratio when it comes to detection. This is just a few obfuscation methods we published over the last couple of months. Again, in the context of, for us, it's not just about making sure we parse the message properly. It's also about using this as an indication of attack. So here you can see that even in this case, even if attackers use a malicious link that Office 365 already knows about, this is the top example, the first one will be blocked. But in the second one, they basically split the HTML into two segments. One of them is called the base href, and the other one is the href itself. In this method, at the time, now Microsoft fixed it, but at the time, and for about 3 months after we reported it to Microsoft, it was going through Office 365, both the default, the EOP and ATP, because they use the same layer for parsing the email, and if hackers find a way to bypass that, they bypass both. And this basically allows hackers to send already known malicious links and just go through Microsoft. By the way, in this case, we tested both Proofpoint and Mimecast as well, as with a few others. Mimecast was not vulnerable to this trick. Proofpoint was. So this was also bypassing Proofpoint at the time. I believe we tested and they fixed this as well. But this is one example of the kind of tricks hackers would use. This is also an interesting one because this goes against Office 365's natural language analysis and probably keyword analysis. So, Microsoft, the team at Microsoft already knows, as every customer knows, that hackers are after their own accounts and are sending emails that look as if they come from Microsoft. So they know to try to identify them, look for keywords, etc. In this case, what hackers were doing, they were using what we call zero font, meaning just defining the letters with a font of size 0, making them just invisible to the end user, and then just putting other stuff within that text. Now, for the machine that does natural language analysis, this looked like this longer string that you can see here. But for the user, it looks like this, 2018 Microsoft Corporation. Going back to what I described earlier, when we analyze this, we wanted to make sure that our natural language analysis doesn't fall victim to this. And by the way, this is an example where at the time we were vulnerable, and the correction for the parsing was to analyze the email both in its full size as well as getting rid of all the zero size font and doing another analysis of the words there. So improve the rendering so it's closer to what the end user would see. But more importantly, this became an indicator. So every time we see an email with font size 0, that's by itself an indication of attack. In this specific example, we saw that, I don't want to say 100%, but 99.99 something of emails that were using font size 0 were actually malicious emails. So it became almost like, it's an indication of compromise that doesn't require a lot of AI, almost like a static layer that allowed us to identify these attacks. The next item is we don't just connect to email. And again, I'm going back to your traditional email security, putting an MTA, a secure email gateway in front. All they see is the SMTP traffic coming into the organization. When we connect to your Office 365 or your G Suite, we connect to all the services, to OneDrive, SharePoint, Google Drive, etc., that are provided by Microsoft. So different discussion why it's important to look for malicious files, etc., in OneDrive, but just in the context of email, being able to analyze links within SharePoint, etc., really gives us the ability to find malicious content that if we just analyze the email, we wouldn't be able to open. And this is an example of an internal attack that hackers were using, and we published recently. We called it Fishpoint attack. Basically, the way it works is that someone compromises an account and then just shares a file on OneDrive or on SharePoint in this case, that is a PDF, a malicious PDF. In this specific example, it was malicious because when you open the file, what you see is a 100% genuinely looking Office 365 login page. So think about your user; they're getting just a regular, SharePoint message with an internal email from an internal user telling them, open this file. They open it, they are required to authenticate again, also looks very legitimate, and then they lose their credentials. And again, in this case, because we were able to analyze SharePoint and scan SharePoint, not just the email, we were able to see this as soon as it was uploaded. For malware, we did a lot of analysis when we wanted to choose our malware engine. And we basically ended up providing our end users the option to choose. So when you run our platform, we come with a default set of tools, but you can also pick and choose your own. And we really picked, the best vendors out there. I think the statistic was that on every 5 vendors we tried, we only put about 2 on our platform at the end. So, if you have reasons to prefer one over the other, you can always use it. Unrelated side note, you don't need to worry about licensing in the sense that, when you buy our platform, we'll provide the license for the third-party tools as well. We also support a BYOL method. If you already have a Palo Alto Wildfire, you can use that. But generally, it's not just an integration. It's incorporated into our platform, and you'll soon see the examples. It's just part of the mail flow as it goes. By the way, some of our customers would choose more than one engine and would use more than one engine. No problem to do that. We scan in parallel with all the tools you chose, and then based on everyone's result, we make a decision whether we should block the email or not. So this sort of shows this concept where, why the layered approach would work or, would become so effective. And even though it's portrayed as if they're scanned one after the other, they're actually all scanned in parallel, and then we make the decision. Okay, so far still we focus pretty much on email, but then when you connect to Office 365, and in general, you should think of the case where an account does get compromised, something bad happens, and the phishing email does go through, or the user loses their credentials in some other way. So for that, we have what we call the anomaly engine. The common term in the industry is UEBA, User Entity and Behavior Analytics. And we track two things. We track the logins, obviously, but we also track everything that happens afterwards. So I hope you can see some of the examples here, but you can see that, this user logged in from Canada for the first time. This is something we would flag, or the third example, I guess, is of a user that logged in from Israel and 1 hour later from the US. So that's what we call the Superman effect, basically indicating that this account might have been compromised. The fourth one is actually also very interesting. This is someone that forwards all their email to an external mail address. And the last one is of a user that created an email rule, an inbox rule that basically forwards all their email from their inbox to the deleted items. The last two examples are interesting because they're another indication of compromise. And the way we get those is we actually have our security analysts fall victim on purpose to phishing attacks to see what they do next. And when we learn what they do next, we use that as an indication of compromise to tell you this account might have been compromised. Now, to forward an email to an outside email address, that might be something that the user did on purpose. And this is when we treat it as an unsecure configuration. So we still give you an alert, but it might be legitimate. But we also have the email addresses that hackers use across all of our customers. If we see the same external email address used for forwarding from two unrelated customers, that's obviously a very, very red flag. So that we jump this into A5. Because when the hackers are lazy and they use one mailbox for everything they hacked, that's a pretty strong indication of compromise. The last example is also interesting because what we've seen hackers do, they sit in your inbox, send emails, trying to spread the attack, but then they don't want you to see the replies. So the reason they create this rule to move it to the deleted items is so that when the email comes in, it actually goes to the deleted items, and they use your deleted items as their inbox, quote unquote. So all of them are just, examples of what we've seen hackers do, added it to our anomaly engine, and now we're able to track those. And I guess on the map, you can see someone from Nigeria. This company has, it's a global company with a lot of locations, but nothing in Nigeria. Obviously, that's a red flag. Okay, the next item is about scanning internal emails, and again it talks about one account that's already been compromised. Answering the question of why should I scan internal emails? And by the way, with all of these, we had loop you into a discussion we had with Gartner recently, and we went with one of the analysts over all of these advantages, and we just asked them to say, low, medium, high, just from their perspective of how valuable this is. When we got to scanning internal emails, he just said huge. So, the scale of low, medium, high was no longer enough for him to describe how important this is. And his point was that he believes a lot of, enterprises and customers don't understand how important this is to really scan all email. The main reason is that very quickly you detect that someone was compromised, in addition to all the layers I mentioned earlier. But being in line on this traffic basically protects your other users and protects your partners and customers from the follow-up attack. So, pretty much with every customer we discuss this, they would say, if I have a compromised account and only my organization knows about it, that's one one level of problem. If they start sending phishing emails to my partners and my customers, now I need to, now it's exposed, now I'm in a different type of a problem. So being able to scan those emails as they go out and being able to block phishing emails, even when they're coming from within, becomes really important. Now, in all honesty, we believe no one else does this. Now, some of them say they do it, and I'll tell you where the caveats are. Even when they say they do it, you ask them how should it be configured. Normally, it's we call it unrealistic configuration. It's a term one of our customers that evaluated another solution before choosing us used. Unrealistic configuration means you just need to go through hoops to make it work, specifically in your Office 365 configuration. The other aspect is that normally they would say, yeah, we would scan it, but they won't be in line on it. Especially if you think about, outgoing email, not being in line basically doesn't mean much because it already left. You already sent that email to someone outside of the organization. So being in line on those is really important. And maybe the last, but the most important thing here is that the algorithms to detect phishing coming from within to the outside are completely different than the algorithm used for incoming email. One of the key things when you analyze email for phishing is to have what's called a social graph. The interconnection between the different organizations and the different users within the organization and so on and so forth. So I've never seen an email from this sender in the context of a phishing attack coming from the outside. That's a pretty strong indicator. But in the context of analyzing internal email, that's almost meaningless. Other parameters like how many emails is this user sending per minute? At what rate? How often does he speak with his second circle of people, the people he only speaks to once a month? All of a sudden he speaks to all of them, within the same hour. Either he's about to, leave the company and that's his farewell letter, or the account was compromised and he's sending phishing attacks. Because no one else that we know of does this separate analysis of internal originated emails for phishing, they really rely just on, even when they scan it, on URLs. So basically relying on the fact that they saw this URL before, that they know the URL is malicious, and then again, they might be able to flag it, not be able to block it inline. So, I hope this makes sense to you. For us, this is a key differentiator in mitigating attack and securing the email environment end to end. Sort of the same, but not exactly the same in the sense that this is if something does get through. What do I do now if something does get through? Gartner started covering this by what they call Mp4. So SOAR stands for Security, Orchestration, Automation, and Response. It's a market of its own, basically, in some respect, the next generation of SIEM, being able to see the information and make a decision and take action. Because 90% of what you would do within a SOAR is actually handle phishing attacks. And this is where, at least based on our customer discussion, where most of the SOC time goes into. Gartner had started talking about mail SOAR, MSOAR. In our platform, we call it search and destroy. But the idea is to very quickly close the loop on the entire phishing campaign that went through. So in this example here, an end user reports a suspicious email, as quickly as marking this within the email they got, hey, I think this is phishing, can you take a look? Within our console, very quickly finding the email, and you can see the screen on the left. So not just finding the one email, the one attack that the end user flagged, but the entire phishing campaign that hit your organization. Every email that fits that email profile. And you can see at the top, you can play with the checkboxes until you figure out, hey, this is the attack. So by the way, in the example here, it's not a real attack, but you can see it's the same email coming to different users, and you can see that they are coming from different IPs. So maybe, the equivalent for a hacker would be that they're using different senders. In some other cases, they would use the same IP. In some cases, we would actually know the IP address of the client, like the hacker laptop, wherever they connect in whatever Starbucks, the IP address they have for using the attack, so you can try to filter by that. But as soon as you create the scope of, hey, this is the attack, this is the campaign, you click one button and three things happen. First, we immediately go back to the mailbox and we remove them from all inboxes. This is that dotted line I had earlier between us and your mailbox, the post delivery. This is exactly where this comes in. The other thing we do is we create a static rule that fits this profile to basically say, we have a gap here right now, just block this, block every email that fits this profile, mark it as phishing. And what that allows you, it allows you to, eliminate the campaign. So if additional emails are coming in, you're going to block them. And then the third part is that this automatically adds to our training set. So with our daily model release, new model release for AI, the AI already had a chance to learn this type of attack. And this helps if the hackers move a little left, a little right, change the subject, and so on, we would still be able to catch it looking at the other indicators within the email. But again, being able to recover quickly from something that went through and eliminate the risk, that's key as well. We're not the only vendors that do this. This is normally what Gartner would cover under their CESS market, Cloud Email Security supplement. Some of the more traditional vendors do this as well. I believe, that no one does it as simple and quick as I just described, where the loop is completely closed from the end user all the way to eliminating this attack end to end. And so this is really, sort of touching the process where people think about AI, people that are not in our industry think about AI, they sometimes think about some brilliant algorithm that, miraculously learns and catches all the phishing attacks. I think we're not yet there. So in reality, AI is really about building an algorithm, training it, finding the right training set to train it, get feedback on the results continuously, refeed that feedback into the training set, and continuously have the machine be smarter, learn better, etc. So this is a somewhat simplistic but a very high level description of the methodology, the process Avanan uses. We took this from a group that joined us, a group of AI experts that joined us from 8200, that's a unit in the Israeli intelligence, the equivalent of NSA. So they sort of replicated something similar they've used there. But the idea being, an email comes in, we have a set of indicators that we look at, several hundred, as I mentioned. The machine learning has, simplistically saying what we call a decision tree to look at all the indicators and all the cross correlation between the different indicators with weights that were already built based on the training set, and then make a decision either clean, suspicious, or phishing. And an analyst team that mainly focuses on the suspicious, on the borderline between is it phishing or is it clean, divided into security analysts that their job is just to make the training set better. So they would say, hey, here's an attack that was missed, let's add it to the training set, or here's a false positive, let's add it to the training set, etc. And a group of data scientists that they improve the machine. So the security analyst improves the data it's trained on, the data scientist improves the machine itself. So finding new indicators, tuning existing indicators, etc. And finally, the last component is the customer. So every time an end user does something, every time something is released from quarantine, every time one of our customers is creating a blacklist or a whitelist, that feeds into this analyst team to expand it to everyone else? Is this blacklist necessary for the other customers? Should I train my machine on something else? Is there a new attack that we're missing right now, etc.? So that's the process we deploy. Obviously 24/7 with 3 locations around the world. Okay, so I want to jump real quick and tell me if you can see my screen into a quick demo. And we spoke about a lot of things. I want to demonstrate just a few of them within the console. So first I'll start with just connecting, and we mentioned this earlier, but literally to connect to Office 365, all you need to do is approve our app within the Office 365 App Store. This is the experience. You need to log in once. I need to be an admin of an account, so I think this is an admin. And let's see if I have the right password. And then, yeah, these are the permissions. You press accept, you're done. That's what it requires in order to connect. We started with a monitor-only policy, so we just scan all the emails, but we don't take any actions. As soon as you're ready to move to protect mode, you can do it on all users, or you can do it on a select users or groups, etc. Again, talking to the fact that with an MTA, you change your MX record, you're done. It's either all or nothing. Here you can, do a POC on 5 users, experience it, then decide, when you're ready to move the entire organization to inline. We have another mode that we call detect and prevent. This is when the mail would go first to the inbox and we'll pull it back. So most CSS vendors, when they say inline, they actually refer to this, that they act after the fact. For us, we have a true inline mode that we patented that really allows us to scan the email before the end user is ever exposed to it. And then you can see the workflow. So it triggers a workflow to say, what to do with malware, what to do with phishing, can the user release themselves, do they require an admin approval, and so on and so forth. Okay, and then it all ends basically on these malware, malicious files, phishing attacks, and I'll drill down into this shortly. I'll skip shadow IT for today, I'll skip DLP for today, it's not our subject, and anomalies that we touched earlier in the demo. Now, if I look at the phishing attacks, you can see the different things that this was flagged on. So within all the indicators, these are the things that caused this to be flagged as phishing. So you can see that the from is saying it's from Microsoft, but the SPF was wrong, meaning someone was impersonating Microsoft to send you an email that looks like Microsoft. We also used the first time that this user ever sent an email. We actually use it a little differently. Even if they send a lot of emails, if you never responded, if no one from this organization ever responded to this email address, we'll still consider it the first. And there's no historical information, and the domain has low traffic, the real domain. Now, the text itself, in this case, is, your credentials got stolen. Both the subject and the email body looked suspicious, and this is where we use the natural language analysis. But you can see how it would report. It went to a user that is not in line, so I can just quarantine it from here. And everything else, all the other attacks that went to a mailbox that is in line, you can see that all of those get quarantined automatically. I can go here and I can choose to restore from quarantine, if I think this is legitimate. Here are some other examples. Brand impersonation, we see that a lot. So many people talk about user impersonation. This is brand impersonation where they use Office 365, and so on. Now, 2 more things to show. First, this is everything in quarantine, but these are the requests from end users to release from quarantine. So you can see here in the policy, if something was blocked, the end user gets a notification. If they say, hey, I need this, they tell you why, and you can choose to release it or not. And obviously dive into the email and say, I actually think it's a phishing attack. So you choose decline. Unfortunately, we see quite a few cases where customers are releasing from quarantine things that are pure phishing attacks. And then the last thing to show, and then we'll wrap up and go to questions. If you look at clean email, so I can go here and I can basically say, show me all the emails. Oops, sorry, clicked the wrong one. Show me all the emails in the organization. If an end user reports something specifically, obviously it's much faster, but I'm looking for a specific email that was clean. And I'll just expand the search a little bit and dive into an email. So this looks like it was a clean email. Not flagged for malicious, not flagged for phishing, but it had PII, all right. Oh, sorry, this is an attachment. I'll go to the email. I apologize. The example I chose is an outgoing email. So I want to choose an incoming email here. Here, incoming PO. Let's see if this wasn't flagged. Okay, so this came as clean, nothing, fun to be suspicious, but let's say your end user reports this and says, this is actually phishing, block this. What you do, you go to that screen that I showed earlier. And this is where you start playing with the parameters to say, show me everything that came from this, with this subject, with this sender IP, etc. As soon as you feel like you got the right population for the attack, this is when you can create a blacklist, and then the 3 things I mentioned earlier, this is when it happens. So this is the demo. Really, just to recap, generally when we compare our solution to others, we look at ATP, that's the Advanced Security from Microsoft, your secure email gateway, that's your Proofpoints and Mimecast of the world, and the CESS vendors, the Cloud Email Security Supplements. Each one of them has their own advantages, that's why they exist, but ease of installation, ATP, super easy, that's our reference. It should be a click of a button. SCGs just don't have that. You need to change MX records, Office 365 configurations, etc. CSS do have that, and the way they deploy is exactly like us. If, Gartner basically cover us within the CSS. Inline enforcement, that's really where they're short. So inline enforcement, they just don't know how to do. Being able to secure all email, ATP sort of. So when you look into the details, they don't scan outgoing in real time, only when they suspect there's a compromised account, and they definitely don't block outgoing email. CSS, some of them say they scan it, but they use the same algorithm, and as we explained earlier, it doesn't work. And CG's, secure email gateways, claim they do, but everything we heard from customers was it wasn't realistic to actually deploy it. Protection of full suite and beyond. So ATP does protect the full suite, even though we see degraded service for Office 365, for OneDrive. So it just takes a ton of time until a OneDrive file is flagged as malicious. And for the other ones, it's just not their focus. They only focus on email. Also, Microsoft just secures Microsoft, right? There's nothing you can do for your Slack or Box or other platforms you may use. The MSOR, this idea of post-delivery protection, ATP doesn't do it. Office 365 has some tools to go back, but eventually customers report that they go to PowerShell. Obviously not the sleek experience I've demonstrated. CSS, this is really where they shine. So, oops, sorry. This is really where they shine. This is their focus. Here we go. And CG, some of them say they have it, so we didn't put a red X, but most of them don't. Layer top existing security. This is one of the biggest problems for SCGs. ATP is another layer. CSS is another layer. And then invisible to hackers, same thing. SCGs is visible. ATP, the sender doesn't know that you have ATP. Same thing for CSS. So most of them are problems within the CEG area. And this is another recent quote from Gartner, where they said large-scale migration to email to the cloud necessitated a strategic shift in how we secure this communication channel. So this is from last month. And then this is when you add us. So we touched all these points as we went through, but these are the areas we focus our product on to help you secure pre and post delivery of email. So just to recap, what is Avanan? We reinvent email security. It's a new way to secure the entire suite. It's an API approach to protect the entire collaboration suite. It's inline pre-inbox defense. And really, this is the reason why other CSS cannot replace your proof point. We're completely inline. You don't need both. You get everything in one. Post-delivery protection demonstrated how even if something goes through, go back to the inbox very efficiently, kill the threat. Smartfish focused on what the default security misses and why that was important. We touched that through the presentation, and how we allow you to choose industry-leading malware vendors for sandboxing and antivirus. We have 5 more minutes left. Any questions from the audience? Michael, did we get any questions?
You can use the Q&A feature now to ask any questions that you'd like. We did have questions come in during the call. The first one is, does Avanan replace the need for user training? Okay,
that's a great question. And I think it's covered a lot in Gartner's literature. It doesn't replace end user training. These are 2 layers that, you must bring to the best, both the machine security and the end user awareness security. In general, phishing is after the end user. It's tricking their brain. So by default, you have 2 layers of security, just anything you filter at the email level, and then everything your end user would flag and know to be phishing. And you should use both. You should absolutely do the best you can for training. I think even Gartner said that with the best training, companies were able to reduce click rate on phishing attack from over 20% to, within the best companies they've seen, something like 5%. So this is why it's a layered approach and a combination, and you need to be best at both. Finally, for some of you, phishing training for end users and for ourselves at Avanan as well is part of the regulation. We do it because SOC 2 requires that we do this training. It comes in with other regulations as well. So short answer is no. It's in addition to making your users as trained, as smart as you can.
That's great. The next question comes from a user, from an attendee. I'm confused about pre-delivery and post-delivery. Do I have to choose between the 2? Okay.
I'm not sure, but I suspect this question might have come before I did the demo, but you don't. It's inherent within the product. Basically, we start in monitor only, so initially we just scan everything. As soon as you move us to inline, this is where the pre-delivery scanning and blocking happens. But then if an end user reports that something was missed, this is when the post-delivery comes in. And again, it's part of the query of the platform. You don't need to configure anything differently. We connect through API, so we can also go back to the inbox and remove emails that were already delivered.
That's great. Now, the last question I have is, what can I do today to improve my email security? I suppose that means aside from buying Avanan.
Aside from buying Avanan, aside from training your end users. So I think one important recommendation to make is to enable MFA, multi-factor authentication within the organization. This is somewhat painful, especially when you look at large organizations. but in the era of SaaS, it's a must. And I can tell you, within Avanan, we make sure every service we use supports multi-factor authentication, not just our email, anything we use. Like most companies that I think statistics says everyone that started out in 2009 never had a data center. So Avanan doesn't have a data center as well. Everything is cloud-based. Therefore, there's no notion of a firewall or perimeter getting into your environment. And this is why it's so important that you don't just rely on user and password. So if I had to choose one recommendation on top of having an additional layer of security and training your end users, it would be to enable MFA.
I do have one other question that just came in late. What are your thoughts about DMARC implementation? You mentioned outgoing protection for email. How do you monitor that?
Oops, sorry, I didn't mean to click that. So DMARC is a must, and I can tell you an example we've seen more than once where when you just enable your email, enable DMARC, and you don't even need to configure SPF. And for just internal emails within Office 365, that's not a big deal. Your organization would be able to use, email. As soon as you start using other services that may send you emails from your organization, Salesforce, Jira, whatever, those will be flagged if you don't fix SPF and DMARC, etc. Those will be flagged as phishing by Office 365. What we've seen some companies do at some point, they whitelist their own domain. And as soon as they whitelist their own domain, what that means, it means everyone in the world can impersonate to you and send you emails. Office 365 would say, this is a legitimate email because you just whitelisted your own domain. So yeah, enabling these capabilities even within Office 365 is just very important. It improves the hygiene of the email and improves the delivery of your emails going out. To fix your DMARC, this is not something Avanan does, but we have spoken to a company called DMARCtion that does that. They do projects for companies that basically want to improve their own email hygiene by fixing DMARC and SPF. I think we're at the top of the hour and I want to be sensitive to everyone's time today. So if you have any other questions, you can actually send them just through our website through the chat window. It will get to us and we'll make sure to answer those. Otherwise, we'll make this presentation and recording available from our website. That's it for today. Thanks everyone for joining and looking forward to meeting you in one of our next webinars.